Alright, let's get started. We need to know what a volume of a line represents. It's not zero, it's its length. And let us represent it by v1 as a function of radius. 1 represents one dimension. So that's just 2r. Suppose I have a line segment. That's the center and that's r. Alright, next the volume of a circle. That's its area. And I've already proved why it's pi r square in the previous video. And it's not so hard. That's also required. And now volume of a sphere. As you all know, it's 4 by 3 pi r cubed. Not so hard to prove. It can easily be proven by taking elemental disks and integrating throughout the length of the radius of the diameter. And that's 4 by 3 pi r cubed. Now let's come to the elephant in the room. That's volume of hypersphere. So that's just V4 of R. Yes, we generate a similar method as this one, for what we have done for the sphere. Instead of taking elemental disks, we take elemental spheres. It's recursive. In the area of a circle, if you remember, I had taken for elementary lines or line segments throughout the diameter. Now, in sphere, I've taken elemental disks. Even that's increasing by a dimension, as you can see. Here I took a lines, here I took disks. Naturally, here I'll take a sphere. Of course, I cannot draw an elementary sphere as we cannot intuitively visualize the fourth dimension as we are three-dimensional beings, but the method remains same. We take an elementary sphere and we multiply it with the next dimension, that's dh, to make it fourth dimension, and then we just integrate it from minus r to plus r. The equation of a fourth dimensional sphere looks something like this, 1 r square. Alright, let's get into the elemental sphere. Let the sphere be at a distance w from the center. Yes. Now its radius would be r square minus w square under root. Yes. No, it's not equal to under root. Yeah, so b r square minus w square under root. That'll be its radius. But we are cubing that, so it's going to become power 3 by 2. Now we're multiplying with the elemental next dimension to make it a fourth dimensional expression. So this is an elemental volume of our 4D sphere. Now we have just integrated. W, of course, ranges from minus r to plus r as it's a sphere. Now what's left to do for us is to integrate this. Let's take all the constants out. 4 by 3 pi minus r to r square minus w square power 3 by 2 dw. An obvious substitution that I can see here is w is equal to r sine theta. Yes. So r square minus w square is equal to r square 1 minus sine square theta. That's r square cos square theta. And of course dw is r cos theta d theta. And when we put r as w, we get sine theta as 1. So theta ranges from minus pi by 2 to pi by 2. Right? We substitute all the values back. Minus pi by 2, pi by 2, r square cos square theta power 3 by 2, r cos theta d theta. Okay, this will become r cos theta whole cube. That's r cube cos cube theta. R cube times r power 4. And we'll have a cos power 4 theta inside, if I'm not wrong. Yes. Alright. We just have to integrate this. Right, let's go to the next page. So we had 4 by 3 r power 4 pi minus pi by 2 to pi by 2 cos power 4 theta d theta. Let's just focus on this for now. Yes. Alright, now we can use integration by parts on integration of cos power 4 theta d theta. We can break it into cos theta and cos cube theta. We'll be differentiating this and we'll be integrating this. And we know by integration by parts that f dash g is equal to fg minus integration f dash g. Here our f is cos cube theta, g dash is cos theta. So applies f dash is equal to 3 cos square theta times sine theta with a negative sign, and g is the integration of cos theta, that's just sine theta. We just substitute in the formula fg. Okay, f is cos cube theta, g dash is cos theta minus, sorry, g is sine theta. F dash is, okay, that's a minus, become plus 3 cos square theta sine theta times g is sine theta. The whole thing with the limits minus pi by 2 to pi by 2. So we separate the limits. This minus pi by 2 to pi by 2 plus the integration of minus pi by 2 to pi by 2 cos square theta times sine square theta d theta. Yes, we multiply by 4 and divide by 4. So okay, first let's substitute this. When we put pi by 2, cos becomes 0. When we put minus pi by 2, cos becomes 0. Hence, we end up with 0. Now for the next integral, we have 3 times the integration of minus pi by 2 to pi by 2, 4 as I said, sine square theta cos square theta d theta. That's 3 by 4 integration sine square to theta minus pi by 2 to pi by 2 d theta. Now sine square to theta can be written as 1 minus cos 4 theta by 2. Simple double angle formula of cosine. So let's just substitute this in the next page. Alright. Let me just change the color to white. Alright, so there we go. So we had 3 by 4 integration minus pi by 2 to pi by 2 sine square to theta. That's 1 minus cos 4 theta by 2 d theta. That's 3 by 4 minus pi by 2 to pi by 2. 1 by 2 minus cos 4 theta by 2 d theta. That's 3 by 4. That becomes theta by 2 times sine 4 theta all divided by 4. And we just insert the limits minus pi by 2 to pi by 2. Right, so this becomes 3 by 4. Pi by 4 minus 1 by 2. Pi by 2 times 4 is 2 pi. Sine 2 pi is 0. And for the minus 2 pi by case also, we have 0 as it's sine minus 2 pi. Still 0. Let's open the brackets. Let's see what we get. Pi by 4. Oh, sorry, even here's pi by 4. Pi by 4 plus pi by 4. That's pi by 2. 3 pi by 8. Alright, so 3 pi by 8 is this. Alright, let's move on to the next slide. Let's change the color to complete white again. Alright, so what do we have finally? The volume is 4 by 3 r power 4 times pi, and that is 3 pi by 8. Cancels. Hence we are left at pi square r power 4 by 2. And that will be the volume of a hypersphere with radius r.